Hello again. Today we will talk about the components of electricity. We will talk about voltage, current, resistance, types of currents, AC and DC, and different types of circuits, close, open, and short. Let's start by talking about voltage, current, and resistance. As you can see in this image, we can use water to visualize how electricity works. As you can see here, water flowing through a house is a good way to look at electricity. Water is like electrons. In a wire, flowing electrons is called current. So this water that comes out of this pipe is, you must imagine it as electronic or electrons. Pressure is the force pushing water through a house. Voltage is the force pushing electrons through the wire. So we have electrons for water, voltage for pressure or water pressure. Friction against the whole walls slows the flow of water. So resistance is the force that slows the flow of electrons. So when the resistance increase, it will decrease the whole amount of water coming out of the pipe. If we increase the pressure forcing the water through the house by opening up the spigot, the water flows faster and squares further. The opposite happens when we reduce the pressure. The water flows slowly, right down to a trickle. In electricity, the force pushing electrons through the wire, current, is voltage. If the voltage is increased, more current flow. If the voltage is decreased, less current flow. Now imagine keeping the pressure constant and visualize what happens when we change the amount of water available to flow through the house. If there is lots of water, the water will flow out at full force. If there is limited water, no matter how hard you push, the water will only flow out at small trickle. In electricity, if there is ample current available, it will flow through the wire at full capacity. If you limit somehow the amount of current, then the current will only flow at a reduced rate. Finally, imagine what happened if you kept the pressure and the amount of water available constant, but restricted the diameter of the hose, like putting your finger over the end. The restriction prevents the all water from coming out, but the water that does come out comes out with greater force. It will square it further. Also, the water behind the restriction actually slows way down to wait its turn to go out of the restricted hole. The same thing would happen if the interior wall of the house was made very, very rough. The water molecules would run into the rough surface and slow down. There is very much like friction. In electricity, the current does not flow through a wire without running into something along the way. There is always some friction, but in electricity, that friction is called resistance. When resistance goes up, the amount of current flow goes down. When resistance goes down, the amount of current flow goes up. Now, you can examine that yourself with a water pipe and test different concepts, but this is a thing that we should mention at the beginning of our course so that you know what are electrons, what is voltage, what is resistance, and we tried to make a real life example using water. Now let's look at this image here to summarize what we have learned. As you can see in A, we have low pressure, so small amount of water. Low pressure and small amount of water is coming in A, while in B there is high pressure, large amount of water. As you can see, the water will go further since the pressure here is high, while in case of large diameter pipe, as you can see, this diameter is way much larger than this, then large amount of water will come out Here the pressure is constant, but the amount of water that came out of here is way much more. This means that this pipe has low resistance in electricity terms, and this one has, these two has high resistance since they have a small diameter, while this one have high resistance. This is the pipe example for voltage, current, and resistance. Hello again. Now let's talk about type of current. There are two types of current. The type is determined only by the direction the current flows through a conductor. The first type is direct current, or DC, flows in only one direction, negative toward positive pole of source. The second type is alternating current, flows back and forth because the poles of the source alternate between positive and negative. This means that if the current alternates from flowing in one direction 1 minute and then reversing to the other direction the next moment, the current is alternating current. Now let's look at this schematic. As you can see, this schematic shows AC current vocabulary. This is the maximum positive value, and this is the maximum negative value, this line and this line. This is the value to be measured, voltage or current. As you can see, starting from 0, it will go in the positive direction, then it will go in the negative direction. This means that this is an AC current, since it goes in both directions, positive and negative. If it only in the positive direction, then it will be a DC. Hello. Now let's talk about circuits. A circuit is a path for current to flow. There's three basic kinds of circuit: open, closed, and short. Open circuits, in which the path is broken and interrupts current flow. Closed circuit is in which the path is complete and current flows where it is intended. While short circuit, the path is corrupted in some way and current does not flow where it is intended. Let's look at this schematic. As you can see here, we have three circuits, A, B, and C. In A, this is a closed circuit. As you can see, this is a battery and this is a bulb or bulb light. Two wires are connected directly to the battery and current flows correctly. Now if you look at this schematic, the battery and the bulb are connected but in a messed up manner, so broken insulation allows wire to touch, producing a short circuit. These two wires are not insulated, so copper appears, and if two wires are connected together in that circuit, this means that there is a short circuit here and current won't flow. In this circuit we can see that there is a battery and a bulb, but one of the two lines is broken here. Breaking wire produce open circuit. That's it for types of circuits. In the next lesson we will talk about volt ohm meter basics, and we will go in depth